this right, I want to understand this. Like it's so this right here has to do with this example. And let me know if can you still see this new screen or
Yep,
no?
yep, yeah, I'm seeing a screen. I'm seeing,
Okay.
yeah, this 4.1 electric current example.
Okay. So it comes from this here. So the f of x is here, which is 5
That's right.
or 4.9 to 5.1. And here is pretty much like the cumulative, the CD. This is the
Yeah,
CDF.
yeah, cumulative density function CDF. Yeah,
No, wait. Is it? Is that
it
the
is.
CDF?
It is.
Okay. Now, I barely learned that the little f stands for PDF
Right.
right up here.
Hmm.
Up here, that's the f of x, little f, so that's PDF, and the big F of x is the CDF.
That's right.
Okay. I need help understanding like this concept, like what is the point of like from here to here? What does it tell us? And pretty much like how to get to this
Okay.
point here.
So go back to example 4.1.
Uh,
Actually, I just used that graph right there. So let me snip in that graph, and that'll. Oh, I I lost your screen. Why is that happening? Interesting. Okay, there it is. Okay. Yeah, so I've got enough here to at least share for this part of it. So let me share my screen and go with this. Okay, so if you're seeing my screen, you see that graph that was given. Is that okay?
yeah. Yeah,
All right.
I see it.
Okay, so f of x, because this is considered a uniform PDF, f of x is equal to 1 over b minus a. And there's a and there's b. Does that at all look familiar to you?
Yeah, and then you said that this specifically right here is a uniform PDF.
Yes.
And there's like a whole bunch, right? It could be like uniform, it can be like there's
Yeah.
a whole bunch, right?
Right.
Okay.
Right. Right. So this one, you start simplifying, you get 1 over 0.2, which equals what? 1 over 2 over 10, which equals 5. Okay. So the area of this rectangle has to equal 1, and it's got a height. Now we can see, it's confirmed right there, the height of 5, and it's got a width of 0.2. So, base times height is 0.2 times 5, which equals 1. So that it just confirms what we already did over here on the right. All right. Is that okay?
Yeah, I'm just writing it down. 1 minus
Okay.
b equals 5.1 minus 4.9 equals 1 over 0.2, which is 1 that okay, 1 over 2 over 10, and then that 5. Okay.
Yes.
And then 5 is our f of x, which is our our PDF, right?
Yeah. Our f of x is 5, but
Okay.
this is only true from 4.9 less than x less than 5.1.
Okay.
So in sort of full disclosure here, f of x equals 0 when x is less than 4.9.
Wait, say that one more time. F of
F
x
of
is
x
equal to
it's equal to 0. It's imagine your line over here. It's 0 for x less than 4.9.
okay, when f of x is equal to 0. No, when x is less than 4.9, f of
Yes.
x is equal to 0.
Yes.
Okay.
So this is actually a piecewise function. So we'll just kind of modify what we've been doing here. So f of x is also equal to 0 when x is greater than 5.1. That's over here.
I thought it was 1.
remember, we're talking about the PDF, not the CDF.
Oh, this is a PDF.
Yes, little f. Little f is the
Okay.
PDF.
Okay, this is okay. Let me see here. So we're talking.
So
Oh, I see.
this
Oh,
has
I
to be
see.
clear before we can move to the cumulative density function.
Okay, got it. Okay, let me write this down here. Okay, so we have 0, 5, 0, 4. That's PDF. Okay. So in essence, my question is this. So what is that thing called there? That's like what is it? That whole thing there, what is that called?
Well, this is your PDF. Your PDF is piecewise. It's defined piecewise.
Piecewise. Okay. Those are like my properties, or what are they? Like what is
No,
that
it's
whole
just
thing?
it's just telling you like what, like for each interval, how it's defined. So when
For
x is
each
less than
enter.
4, yeah, for each. Okay, so everything in red, which I'm about to put in red, is your domain. This is your domain. So you start with the domain. You're like, where am I? Am I less than 4.9? Okay, well then it's just a line at 0.
And
And
the
if you're
other one, so
and if you're between 4.9 and 5.1, it's this line of 5.
I'm trying to think how that. Okay, so if we're less than 4.980. Okay, now if we're between 4.9 and 5.1, you said 5.
Right? Everything on the right here is a description of the graph.
I'm trying to think how you got that, like how you got 5. Like, so the only way to get 5 is by using that formula above
Yeah.
the
Yes.
1 over.
Yes. Because it's uniform.
Got it. So, okay. Okay, that makes sense. F of x, that's the whole formula. 1 minus 5 point, okay. And then finally that 0 there, or no, it's looking at the right. If x is greater than 5.1, it's also 0 because our interval was only from 4.9 to
Yeah,
5.1.
that's right. That's right.
Okay. And then our 5 is coming from this here, from the f of x formula. Okay.
So if this is clear, we can then calculate f of x, our big F of x, our cumulative density function, because that's really what you were asking about,
Yeah.
which is our
Okay.
CDF. Okay.
Okay.
Okay. Now, let me do 2 parts of this and see if it's clear. The first part is 0 if x is less than 4.9, and here's why. We can talk about why. So if you were to integrate from minus infinity to 4.9 f of x dx, that's what this is going to end up equaling 0. Now we can actually do this integral, but let's talk about why. Is there any area under the curve from minus infinity to 4.9?
No.
That's why it's 0.
Okay. So let's just say it was like a different interval. Would we still, like, for example, would, just by looking at the inequality or the interval in this case, would we still have to like, are there any certain situations where we wouldn't be able to know by just by looking at the
Yeah, the middle one. The middle one we have to integrate.
oh, the middle one.
Yeah.
Okay. But the top one and the bottom one,
So
we can.
yeah, so the top one is 1 when x is greater than 5.1.
Okay.
And maybe, okay, I think maybe I'm getting a sense of why this isn't clear. The way you use this bottom one is you just put a number in for x and you use this to calculate it. Whereas in little f of x, you have to do an integral or do something else. Whereas, but this one, the way this big f of x works is it's always giving you left tail. And you simply put the number in to get the answer. So like, let's just assume that this is all we know for the moment. If I asked you what is f of 2, you would go to here and say, oh, 2 is less than 4.9. That means it's 0.
Oh, I see. Okay.
And you'd say,
Okay.
oh, well, how about f of 4.8? Well, where's 4.8? Oh, it's less than 4.9. Oh, okay. That must also be 0. But what if I asked you for f of 5.2? Was 5.2 greater than 5.1? Yeah, so it's 1.
Yeah.
What is f of 10?
The
1.
one.
1. Yeah. And so the real power is when we get a number between 4.9 less than x less than 5.1. Whatever function we get here, we will be able to just put the number in and calculate it rather than doing the integral.
Okay. Let me write this down here.
So it's almost a choice.
Okay. And then it seems to me like here, let me write this and then I'll ask. Let's see how okay. Less than 4.9, that's 0. Then you have 1, x greater than 5.1, and then finally 4.9, the interval x. So what number like are we gonna put there, like in the middle?
It's end up being a function. So in the middle here, so to do the middle one, we have to integrate our probability density function. Okay, and this is what you saw in there. It's 4.9 to x 5 dx, because 5 is your PDF. Okay, 4.9 is your lower bound and x is your upper bound.
Why are we going from 4.9 to x? Why not x to like 5.1?
So the way the integrals work is it's always the lower, or which is the left number, to the upper, which is the right number. In this case, your left is 4.9. That's where it starts. And your upper your upper in this case is assumed to be less than 5.1, because that's the right hand side. That's the bound of it over here on the right.
Oh, I see. Because we're looking for that x that's just in the middle. We know that it's less than 5.1, but we don't know what the value is.
Right.
Oh, I see. Oh,
Okay. So you as a student have to be able to do this right here in blue. You have to be able to do that calculation.
yeah,
Okay.
yeah.
And that calculation is 5x evaluated from 4.9 to x. So as a review here, whenever you have a constant times dx, the integral is cx. Okay, so this becomes 5. Now, instead of x, you put in the upper bound minus 5 times the lower bound. So it's 5x minus 24.5. And that is what goes in this position up here.
Uh, I'm gonna just write this down
Sure.
here.
Yeah. And then we should do a few examples so you can get a feel for it.
Yeah, so yeah, 5x, okay, minus 24.5. Okay, so it's this here. Can you scroll just a little bit above, a little like above that, just so I can look at that. It's a
Where,
little bit that,
where do you want me to scroll up or down, or which direction?
uh, yeah, up
Is that
or
better?
sorry, or down, sorry, down.
Is this good or not?
No, sorry, I meant down. Right there, yeah.
Okay.
So you did negative infinity to 4.9. Okay, that was like the example of what's going on.
Yeah, that's actually for this one over here.
Okay. So that's okay, what's going on, because we're going from negative infinity to 4.9, which is 0. Dx goes 0. And we're going from that is our PDF. Okay. Would it be possible to scroll down now just a
Of
bit?
course, of course.
Okay. And then you're going from 5x, 4.9 to x. Minus 24.5, which is this. Right. And then yeah, no, that's for it. Okay. And then so what the only so I'm trying to kind of like look at the entire or like both the little f of x and then f of x.
Sure, yeah.
So the difference between both is that so for f of x, which is the cumulative the CDF, for
The
that
time
one
it
we
big, this big one down here. Yes,
for that one for the CDF we integrated, and
yes,
then for the PDF we didn't have to integrate.
no.
Okay.
And I mean, notice if you take the derivative of 5x minus 24.5, you get 5
Okay.
up here.
So so really the I guess you could say it's I mean it'd be debatable, but I think most people would agree that the most difficult number to find is the one in the middle.
Yeah,
And
it's a function because you can evaluate it now. Like if I asked you for, and this is a good one to do, f of 4.9, if you do 5 times 4.9 minus 24.5, see how I just put that in there?
yeah,
You get a number out. You get 0 in this case.
5, 4, 4, okay. And then like so for example and then like going back like to the middle number,
Mhm.
so for little f of x you're gonna plug it in into the PDF. No, no, so yeah, into the PDF formula. Oh no, no, sorry, the f of x formula.
Yeah, you're almost never going to put a number into this f of x little f of x formula. That's just
Yeah,
not going to happen. It's in here in the cumulative density function.
okay. So for little f of x, that middle number, if you do get one and you have to evaluate, you're gonna plug that little no, or you're gonna use the interval numbers and plug them into the f of x to
Yeah,
find the f of x. But for CDF, you're gonna actually whatever number, or actually in order to find the f of to find what would those numbers be again? The 0 and the 5x minus, yeah, those, like, what would those numbers be again?
what do you mean?
Are those like f of x's or x's? What are they?
The 0 and the 1 here?
Yeah.
They're the actual, like, what is the cumulative probability up to that point? That,
So
like,
they're
they're the output. That's the
the
output
output.
there,
Okay, so
always.
I'll say output. Now, when you have in in the middle that output that you're given, in order to find the one in the middle, you're gonna have to get your lower bound. So integrate from your lower bound to
That's
and
right.
to the unknown x.
Yes, that's right. Lower. That's really well said.
Okay. All right. All right. I think I got that one. I have a different homework problem too.
Okay. Yeah, you can either send it over or you can share your screen, whatever you would prefer.
Okay, let me see here. How do I just minimize it? How do you minimize like the actual what the heck?
You may have to exit full screen view. Should be an option there. on that.
Oh, there you go. I see it. Okay, cool. Okay, let me see here. What was the? Okay. Okay. So now let me see example 4.4. Okay. If I share my screen, like you can see a video as well, right?
Possibly, yeah, depending on what it
Okay,
is.
awesome. Okay, cool. Yeah, so pretty much like I have a video how to do the problem. But like there's steps in between, or at least one step. It's pretty much like an integral. And like I didn't understand how to like.
Okay, well, go ahead and share your screen. And I'll take a look at it.
All right, share screen. Do you want to this will stop with it? Yes. Okay. Should be this one. Okay. Okay. Are
Okay,
you able
yeah,
to see this?
yep, yeah, I see a video. You hit the play
Okay,
button
cool.
there.
So
I'm not
yeah.
hearing anything also, but that's probably not important.
Oh, you can't hear?
No.
Oh, it's not. Okay. Well, yeah, it's not like really too important. Like my question was this here. Let me see here. Once we get to the like the actual computing of the problem. Okay, right here. Okay. Right here. So actually I'll expand it that way you can see the work. It'll be easier. Okay. So my first question is this here. Okay, let me write this down here. Okay. And just to check, are you able to see the screen?
Yes, I see
Okay.
everything. I think
Okay. So now this right here on the in the bottom here, this okay, let me see. This is just okay, right here. This is the antiderivative, right? Right here.
the thing you're pointing to is the derivative of the cumulative density function. It's the derivative of that 1 minus e to the minus 0.01x.
So this right here is us doing the derivative or the integral
Derivative of the thing on the left.
on this right here.
Yes.
Okay.
And
So
that graph above it is the graph of the function 0.01 e to the minus 0.01x.
okay. Now let me see here. Okay, and then this is the integral of this right here.
Yes.
Okay.
The,
So
the, okay, go ahead.
oh, I was gonna say like can we like yeah like I mean like I kind of like I forgot Calc 3. I should know this
It's
like
fine.
the back of my head. But that's my question. I need help with like figuring out the like how to work out the derivative and the integral.
Sure. I'll share my screen here. Is it clear though that they're trying to show you that you either do it the way on the right or you do it the way
Yeah,
on the left, and it doesn't really matter, but you have to understand that you have to be able to do both.
yeah. Which by
Okay.
the I mean that's like even like I mean I kind of understood this here, but not really to be quite honest. I'm like that, but at first I really just want to have the basics down. Like if I can't even
Okay.
figure out the integral, the
Yeah. Okay. So let's start with let's say I give you y equals e to the x. The derivative is always itself. Are you seeing my screen now?
yeah,
Okay.
yeah. I
Now
remember
that's
that.
now
Yeah.
that's not very useful. So what if it's e to the ax? Well, the derivative is e to the ax times a because of, if you recall, chain rule.
Okay. Let me
Okay.
see.
So this simplifies to a e to the ax. Now, what you're asking about is, let's say I give you something like e to the minus 1 over 100x. What is its derivative? Its derivative
Okay.
is,
Oh, let me think. Let me think. So, okay, let me think here. Let me use my head a little bit. Okay. So this is the derivative. So the okay. What I would personally do, actually I have no idea.
well,
I don't know.
it's this example on the right here. The derivative is itself, okay,
Okay.
times the derivative of the inside function. What is the derivative of minus 1 over 100 times x?
That'd be
It's
just a -1/100 because you get rid
That's
of the
right.
x.
That's right.
Okay.
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 Now in your problem, they use decimals. So we'll do one with decimals now. So let's say I tell you that y equals e to the minus 0.08 x. Okay.
Okay. So
What is
you would do. So you would do e to the same thing to the power of -0.08x times negative point zero 0.08. Yeah.
perfect? Perfect. Okay. All right. So that's derivatives. Okay. Now we're going to do integrals. Is that okay? Is that okay? Do you have any questions on this? Do you want any more examples?
I'll look. Actually, can I write that down?
Of
Is that
course.
okay?
I'm going to
Okay.
send you a PDF at the end also. Check your spam if you don't see it, but yeah, go ahead and get it
Okay.
down if you would like.
All right. Can I get the one at the top too? I'm not sure what it was.
Yes,
That one. Okay.
there
All
it is.
right. Question. Oh, Matthew.
Yes,
That third one there. What is that? The y prime equals a times
it's that
e,
that's
and
an
then
A. Yeah,
that's
it's
an
an A.
that's an a. Oh, okay. Okay.
Yeah, it's meant to represent whatever coefficient is in the exponent there.
Okay, so so again, and then just for that y prime, so right there, you're saying you're bringing. Well, actually, what's going on actually there in
You,
that
you
last one?
I just rewriting it out in front.
Oh, okay, okay, okay.
The rewrite step. So the good news is you don't have too many integrals in this course that are complicated. They're very basic. So a quick review of
Yeah,
calculus will help with this.
yeah, I'm glad as well. If not, I would have been done in this class. I just forgot like it. I just forgot my calc.
Yeah, but you'll be okay. You're spending the time here to figure it out.
Okay. And then you have like down there y equals e negative 0.08 x. Then you have y prime that e negative 0.08 x 0.08. Okay. And then that's the second. Oh no, then I'm missing one more. Y equals e. Okay. I think that was it, right? That
Yeah,
was
so let's go back and look at your question, which I don't know why it's not.
I don't think I'm doing anything, am I?
No, I'm just having my thing here isn't giving me what I want. Um, Let me stop sharing for a moment here. All right, so menu share. All right, so the if we go back to your question, which is this one right here, they're basically asking for the derivative of this right here. If your y equals 1 minus e to the minus 0.01x, the derivative is, and there's a little bit more here, okay? The derivative of 1, the derivative of a constant is always 0. This subtraction has to come down. Okay, and it's just like we did before. It's e to the minus 0.01x times, what's the derivative of the inside part? It's minus 0.01. Okay, so then you can simplify a little bit if you want. So these two negatives go together. That makes positive. E to the minus 0.01x, and instead of leaving this 0.01 off to the right, we would put it in front.
And that's how they got it. And then that's how they,
Yes.
all right, I see how they, okay, now I see how they got it. And then it looks like for some weird, well, not weird reason, but then it looks like underneath, then they went and got the integral of that.
Right, and we can talk about how to do that if you would like now. That would be
Yeah,
good.
I'm gonna write this down
Okay.
real quick.
All right, and I can also give you one like this if you need.
And then-
So another thing here, Alex, that I'd like to just mention is that what you're doing here is when a Poisson distribution turns into an exponential, and you will see this on your exam. Like you will have to integrate something from 0 to 3 or something like that. One of these exponential functions.
Oh wait, actually this is very important. Wait, so what about Poisson and exponential? What
Well,
about those two?
the question is going to read. It's going to like this is the standard test questions. They say something is distributed this way where it has a mean time between incidents of, I don't know, whatever, 2 minutes. And it'll be what's the probability of less than one incidence or something. And you'll use the Poisson distribution for that. But then the part B will say, what's the probability of no incidences in the first like 8 minutes? And that will be some sort of exponential problem that you'll have to integrate. So that's why this is here. Just so you they're not gonna ask you to, they're not gonna give you f of x. You're gonna have to come up with f of x and then integrate it based on some information they give you.
Got it. So you're saying that they're only gonna give me like 1 minus e to the power of negative 0.01?
I'm saying you're gonna have to figure that out. And you're gonna know that because there's gonna be some wording in the problem that tells you that it's Poisson or it's some sort of thing that happens over it's like a counts per cycle type of example. Something that it will tell you like this is a Poisson to exponential problem.
Okay, yeah, that's the next thing. I think like when we meet up again, I think it'll be like, I don't know if it's gonna be one or for sure once more, but it could be twice depending on your
Sure.
schedule. But yeah, right now what I'm trying to just do is like kind of get these questions down and then like I'll start doing with all that stuff.
Okay. So if you got all this down, we can either do some integrals or you can share a new problem you want us to work through. What would you like to do next?
Yeah, just another homework problem because I already did the homework, but it's just like remaining questions that I had on it.
Okay.
Okay.
So go ahead and share whenever you're ready.
continuous. Okay. I was having a hard time with this one. Oh, I see. Oh, okay, I remember this one now. Okay. Got it. Okay. Um, this one here. Okay. Okay. Are you able to see my screen?
Yeah.
Okay. So this one here is a little bit tricky. So it says suppose f of x equals 0.125x, 0 to 4. Determine the mean and the variance. So the mean, for that one there, let me look at the formula.
So this one's going to require an integral, and you actually can use your calculator to do this. So let me share my screen, and I'll show you how to do it.
Okay. For that one, I guess like what I was like wondering was like the actual formula itself, because the way that I got it correct, I don't, which is kind of weird how I got it, because I think if I'm not mistaken, the formula is, here I have it here.
If you're seeing my screen, we can talk about how to do this. So if you integrate this function from 0 to 4, this should equal 1. Okay, and that's like your starting point. This is your f of x up here. This is your a. This is your b. You should always be able to integrate it and get 1 like that. That has to be a starting point here. So to find the mean, the expected value of x, there is a formula, and the expected value of x is the integral from a to b f of x times x dx.
Got it. So it is times x.
It's times x. So in this case, it's 0 to 4, 0.125x times x dx, and it will not equal 1. I mean, it could equal anything. It's going to be some number in this interval here. So if you have your calculator handy, we can get that number. We do need that number for the next part. I will also
Okay.
calculate it here.
Right now, what I'm trying to figure out is that integral formula, is that the mean formula, or is
Yes,
that,
yes, that's the mean. This is the mean.
okay, let me look it up here, because I just wanted to see if I had that right. I was
Now,
confused when I,
now, because this is linear, this PDF, there might be a shortcut for it, but this is true for any probability density function.
and this is a uniform, or what is this?
No,
Or,
this is 0.125x. I mean, if you were to graph it from 0 to 4, it looks like this, something like that.
okay, but would it be
From 0
considered
to
like
4.
would it
No,
be
it's
considered like a continuous uniform, or like a
no,
normal PDF?
no, because continuous uniform is a rectangle.
Okay, so I'm
You,
trying to
so,
figure.
so you got to be careful here that you're not like trying to like assign rules that only work in certain situations. This formula works for any continuous probability density function that I've given you.
Okay,
There
because,
may be, go ahead.
oh, I was gonna ask, like, what I'm trying to figure out right now is, well, let me ask you this: what would be the mean formula for once we get this answer here? What's the mean formula? Like, no, not the integral version, but like the actual,
It's a number. The mean is a number. We're going to get a number here when we do this integral.
I'm trying to figure out where's this formula coming from.
Which one? The one on the left?
Yeah, I'm trying to look for it here on my sheets of
This is
paper.
always true for a PDF, for continuous PDF. This is always true.
Continuous. Oh, okay, yeah, continuous uniform PDF.
But it's not just for uniforms. Like it works for other distributions. You know,
Oh, got it, got it.
and like in truth, uniform, you wouldn't use this integral because the formulas are fairly straightforward for it.
Yeah, I
For
see what you're
if I
saying.
go back to the uniform, the mean is the middle number.
Yeah,
Okay. And
it would just be A plus B over 2.
right. And the variance is like b minus a squared over 12. Okay.
Yes.
Because it's continuous uniform. But it's a lot to remember if you want to remember those for every single one. Now maybe you get a cheat sheet or a 1-page reference, but this is
Yeah.
going to always work. This is your
Okay,
fallback.
let me write this down. Actually, that's really important then.
Yeah.
Okay. And you're right, actually, that really connected the dots because when I'm looking through all my notes here, they're printouts. So I know that for sure there's no mistake, unless the instructor made one, which I don't think so. But I'm looking at all of them here, like the continuous uniform, like CDF, and you're right. So the formula is that for it's x times f of x d of x, which is what
Yep.
you have,
Yep.
and then you have for when I go to the normal PDF as well. Um, it is also, yep, the integral is also x times f of x d of x. So literally that formula that you're saying is for all the continuous distributions.
That's right.
Got it.
Yeah.
Now, the last thing here, that's how, I guess,
We got
for
to do
example,
variant. We need to do variance also. I
yeah,
mean, at some point here, so you can see this.
exactly. And then I guess my last question for just to connect the dots here, why, for example, and I wish I could show, maybe I can, but
Yeah, you can share your screen anytime if you think that's helpful. Go
well,
ahead.
I guess I could just send you. Oh, you know what? Let me send you a picture of what I'm looking at
Okay.
here. I guess this is what I'm trying to say here. Like, let me see here. Okay, like so, like this. Okay, okay. So the picture. I guess this is what I'm trying to figure out. Like that image that I just sent you there.
How did you send it?
Just a
Oh,
photo
there
like
it
free
is.
text.
Okay. All right.
I
So,
this is what I guess what I'm trying to kind of word, and what I'm trying to make sense of. So you zoom in, you see where I highlighted mu equals E of x.
yeah, I'll get it. I'll get it up on the screen here in a moment. Well, we'll grab it here so we can both look at it.
Okay. And just to kind of, so I guess my question would be this because they have a bunch of things where it says mu is equal to E of x, which is equal to the integral of the formula that you just put, which is equal to like you know, to 1 by b minus a, which is equal to a plus b over 2. So
Mhm.
I guess my question is like there's a whole bunch of stuff there for e of x, which is the mean. My question would be, can we just like, yeah. So you see how there's a whole bunch of things there, like mu is equal to that, to this,
Mhm.
and at the very end you have a plus b over 2.
Yes.
Like why? Like I guess if we're looking for the mean. So you're saying that, okay, so in this case, we wouldn't use that a plus b over 2 because it's not a uniform.
No.
But if I can figure out what distribution it is, can can I use the most simplest
Yes.
formula for the mean?
Yes. So what you're asking here is like, let's just say this was your cheat sheet for the exam. You would say, okay, if the distribution is continuous uniform, okay, you would want to know, oh, the mean is always a plus b over 2. The variance is always whatever it is, b minus a over the square, well, b minus a squared over 12. Okay. And then let's just say it's the triangular distribution, which maybe you haven't seen yet. You know,
Oh no.
it's got another mean, another variance. So like for every one, you're gonna have one of these.
Okay. So in that example that we're looking at, what distribution is that?
What, this is continuous uniform.
No, the one that the from the actual question itself.
It's not, it doesn't have a name.
Oh,
I mean, it could be a triangular, it could be a trapezoidal distribution. These are made up kind of things. They're not, it's rare when they actually have a name. Like more often, you're going to be given f of x equals something.
okay. So
And,
there's really okay.
and then your mean is the integral from a to b f of x times x dx.
Got it. Oh, so we're gonna it's found it's kind of like almost there's no way getting out of the integral.
That's right. That's right.
Oh,
Now,
okay.
thankfully, you can do it pretty quickly here with technology. You know, I just plug this into my calculator up here and I got, you know, that answer.
Yeah, I think I get it. I think I can get it as well. Here, let me see. The only thing that the last time you were kind of telling me about was how to like store a value. I'm not sure how to do that with mine. I'm sure that there is a way because I have it's very similar to yours, but I just don't know how to. I can't find the store option.
Yeah, so it's you're using a TI-84.
TI, yep, yeah, TI-84.
I mean, in this case, you're just going to use math 9. You're going to put your bounds in, and you're going to write point instead of 0.125 x times x. You're going to write 0.125 x squared. You don't have to store a value into x for this one. But let me go see if I can find what you're asking about.
Actually, I didn't get the. Oh, how come I didn't get the same thing as you did? That's weird. Hold up. Enter 0 to 4. Then you have 0.125. It is 0.125, right?
Yes, yes.
And then you have, yeah, x square,
Mhm.
x square. Hey, yeah, d of x equals. Okay, there it is. 2.66 or 2.67. Yeah. Okay, I got it. But yeah, that was my question there. Because like when I did it by hand, I was like, why am I getting the correct answer? But where's this extra x coming from?
Yeah, it's always in the formula. So the variance of x, we should talk about that really quickly here. The variance of x is the expected value of x squared minus the expected value of x all squared. And this right here is the mean. That's the number you just came up with.
Okay.
Okay. And then this part right here is the integral from a to b f of x times x squared dx. So this one on the right is the number we just found. We have to calculate a new number to get the answer here.
Don't look for that formula for the.
Yeah.
Wait, how did I do it?
So Alex, my sessions only go 50 minutes. So unless you got a really quick question, we're gonna have to stop pretty soon.
Um, let's see here. Yeah, no, that's pretty much it. I think I'm gonna go to your website right now and then try to put another session with today's Tuesday. So
Sure.
I'm probably thinking like either Thursday or Friday, but probably for like maybe like a 2-hour session.
Okay. Yeah. Take a look and see what's.
Hello?
Yep. You there?
Oh yeah. Oh yeah, and then Matthew, if obviously there's nothing open there, like
Just text me and I'll figure something out. I'll work you in somehow.
okay. And then really quick here, I guess last but not least, just that formula there. Um, you said that's the formula for variance?
Yes.
Because maybe be a square minus, oh, I see. Wait, so how, and then lastly, how come we're using that formula instead of like the simple one, the b minus a square over 12?
Because this one works for every distribution and the b minus a squared over 12 only works for continuous uniform.
I see.
And the one we have is not continuous uniform. So you really got to get out of the mindset of like, it's not formula driven. It's if sometimes the formulas are there, but you should learn the complete formula.
Got it. And then very last, you actually go back to the original question. Yeah, that, or not that, like the actual, like question, like,
Mhm.
there we go. Okay. Got it. Just based on that, there's no way to figure out what distribution this is, right?
Yeah, it's not a known one. It's just a given, just
Got it.
one of many. All right, Alex, thanks so
Got
much
it.
for scheduling. I'll send you the notes here shortly, and I'll see you next time.
All right. Thank you, Matthew.
Have a great night. Bye now.